Hello everyone. This video we are going to talk about the algebra of matrices. Matrices is the plural of matrix. We are going to see how do we equate two matrices, how do we add, how do we minus, how do we multiply two matrices, how do we multiply a matrix by a number. So those are the things we're gonna cover in this video. The first thing, what does it mean? What does it mean when we say two matrices are equal to each other? Let's say we have a matrix A and B. Two matrices are equal to each other if and only if A and B are of the same size. And their corresponding entries are equal. And their corresponding entries are equal. For example, if A is 1, 2, 3x, 4, -5, we know this matrix equal to the other matrix 1, 2, y, 1, 4, -5. In order for two matrices equal to each other, they need to have to the same size. They need to have the same size. Means the number of rows, number of columns would be the same. This one is 3 by 2, right? This is how do we denote the order or the size of a matrix. 3 rows, 2 columns, so this one is 3 by 2. On the right hand side, we also have a 3 by 2 matrix, so that is okay. Corresponding entries equal. 1 equals 1, 2 equals 2. Then what is y? Can you tell me what is y? Y, of course, need to be equal to 3, right? And what is x? X is going to be 1. So 4 equals 4, -5 equals -5. All right? So not any, it is very strict. It is very strict when we say two matrices are equal to each other. They have to be exactly the same. Not only have the same size, but also the corresponding entries equal to each other. So that's the first thing. How do we understand two matrices equal to each other? Second thing, how do we add or minus two matrices? Example 1. A equals 3, -2, 1, 0, 0, 5. B equals 4, -5, 3, 0, -2, 2. Find A plus B. Important thing here, not any two matrices could be added together or take the sum or take the subtraction. Only two matrices have the same size could be add or subtract. So I'm going to write this sentence here. Only matrices with the same size can be added or can be like subtracted from one from the other. You know what I'm saying here? So when we add two matrices together or subtract one matrix from the other matrix, we could only do that if the two matrices are the same size, have the same size. So look at our matrices A and B. Do they have the same size? This one 3 by 2, this one 3 by 2. Yes, they do, right? So then that's fine. We are able to add them up. You're going to see how do we add them up. The addition matrix is going to be a matrix 3 by 2 as well. 3 plus 4. So you would understand very quickly. This is pretty straightforward. -2 plus -5, -7. 1 plus 3, 4. 0 plus 0, 0. 0 plus -2, -2. 5 plus 2, 7. Here we go. We are done. Is that simple? So when we add two matrices with the same size, we add their corresponding entries. The addition of two matrices still a matrix. They all have the same size. Okay, so this is example 1. That's the second thing. How do we add two matrices together? Example 2, I'm going to show you how do we multiply a matrix by a number. We have a matrix B 4, -5, 3, 0, -2, 2. We need to find -3 times B. First thing we need to know, a number times a matrix, the result is still a matrix. The size of the matrix remains the same. So -3 times B, you would understand this also very quickly. Because B is 3 by 2. -3 times B is also going to be 3 by 2. So the 6 entries, 5, 15. -3 times 3, -9. -3 times 0, 0. -3 times -2, 6. -3 times 2, -6. So is that is that simple? You multiply a matrix by a number. You multiply a number by a matrix is equivalent to you multiply each entry in a matrix by the number. All right? So I believe you know how do you subtract two matrices, right? So for example, this the product of two matrices is still a matrix. The size of the matrix is gonna be this. Okay, gonna be 2 by 3. So you determine the size of the matrix first. Then you have a clear mind. I'm looking for 6 entries, right? So how do we find this entry? Look at it here. Row 1, column 1. Multiply the corresponding entry and add them up. 2 times 2, 4. 0 times -1, 0. So we have 4 here. Row 1, column 1. We got an entry in row 1, column 1. Row 1, column 2. We do the same thing. 2 times -8, -16. 0 times 0, 0. So -16. Row 2, column 2. Row 2, column 2. So after this problem, I think you should be able to understand the method. Okay. Row 1, column 3. Row 1, column 3. 2 times 3, 6. 0 times 5, 0, so 6. Row 1, column 3. Row 1, column 3. So do you see the pattern though? Row 2, column 1. -1 times 2, -2. 3 times -1, -3, -5. Row 2, column 1. Row 2, column 1. You see the pattern? Okay, let's continue. Row 2, column 2. -1 times -8, 8. 3 times 0, 0. So 8 plus 0 is 8. Row 2, column 2. Row 2, column 2, right? Row 2, column 3. -1 times 3, -3. 3 times 5, 15. -3 plus 15, 12. That's how do we multiply two matrices together. So method 2. You might like similar but more organized. We're going to make a table here. We are going to make B, right? So the first row of A here, second row of A here. And we are going to put a column 1 of B here. I know it's a column, but you're going to put it of B here. I know it's a column, but you're going to put it horizontally. That's column 1 of B, right? And then column 2 of find a 6th entry, -1. 2 times -8 plus 0 times 0. 2 times 3 plus 0 times 5. Here, -1 times 2 plus 3 times -1. Here we have -1 times -8 plus we have -1 times -8 plus 3 times 0. And this is -1 times 3 plus 3 times 5. So the result is going to be a 2 by 3 matrix. 2 times 2 plus 0 times -1, that is 4. That is -16. That is 6. This is -5. This is a +8. That is 15 minus 3, 12. Which method do you like? Either way, okay? Just be very careful. Example 4. We have A equals 2, -8, 3, -1, 0, 5. B equals 0, 4, -3, 11, 7, 1. We need to find A times B and B times A. Let's first determine, are those two products well defined? A is 2 by 3, B is 3 by 2. So this is 3 by 2, 2 by 3. Do you see they are equal, right? These are equal too. So both of the two products are well defined. But A times B gonna be 2 by 2. A times B gonna be a 2 by 2 matrix, and B times A is gonna be a 3 by 3 matrix. Okay, so we're gonna do row 1, column 1. Do you remember how do we do that? So I have my notes, and B times A is gonna be a 3 by 3 matrix. All right. So in this case, both A times B and B times A are well defined, but however, they are not the same. Obviously not same, because A times B is a 2 by 2 square matrix. B times A is a 3 by 3 matrix. Of course, AB and BA not equal to each other, right? Example 5. We have A is a 2 by 2 square matrix. B is a 2 by 2 square matrix as well. So we need to find A times B and B times A. So let's see if they are well defined. This is 2 by 2, 2 by 2. Yes, they are both well defined. And A times B is going to be a 2 by 2 square matrix. B times A is going to be a 2 by 2 square matrix as well. However, if you practice here, and you will find A times B and B times A not equal to each other. So from those examples, we can derive a very, very, very important fact or conclusion. The conclusion is generally AB not equal to BA. If we have two numbers, let's say 2 and 3, we know 2 times 3 equals 3 times 2, right? The multiplication satisfies the commutative, what is the name? Commutative property. However, if the two things are matrices, definitely not. Definitely not. From example 2, example 3, you can see AB is well defined, BA is not even exist. From example 4, you can see both A times B and B times A are well defined, but A times B is 2 by 2, B times A is 3 by 3. Of course, they are not equal to each other. And example 5, even both AB and BA are well defined, and it turns out they have the same size, but they are still not equal to each other. Okay, so very important fact. Generally, A times B and B times A not equal to each other. Okay, this is section 10.5, 10.4. Thank you for watching.